In this chapter, we are going to begin looking at chemical quantities, and we do that with something called the mole. When I say have a dozen eggs or a dozen donuts, you know that I'm talking about 12. So 1 dozen eggs means you have 12 eggs. 1 dozen donuts means you have 12 donuts. Similarly, in chemistry, when we talk about a quantity, we use the number mole, which is Avogadro's number. 1 mole equals 6.02 times 10 to the 23rd particles. You can see how large this number is written out beside the picture of the mole. 1 mole equals 6.02 times 10 to the 23rd representative particles. Those particles can be formula units, molecules, or atoms. 6.02 times 10 to the 23rd formula units will represent ionic compounds. Remember, an ionic compound is when you combine a metal and a nonmetal, or a cation and an anion. Some examples of ionic compounds are sodium chloride, magnesium chloride, and ammonium phosphate. 6.02 times 10 to the 23rd molecules are your representative particles when we're dealing with covalent compounds. Remember, covalent compounds are when you combine 2 nonmetals, like carbon dioxide, nitrogen trihydride, nitrogen dioxide, or any of your diatomic molecules, oxygen, hydrogen, nitrogen, fluorine, chlorine, bromine, and iodine. 6.02 times 10 to the 23rd atoms is your representative particle when we're dealing with single elements. So any element from the periodic table that's by itself, such as lead, sodium, sulfur, or phosphorus. Let's try a sample problem. How many moles of gold are in 7.28 times 10 to the 28th atoms of gold? We start with our unknown, how many moles? The abbreviation for mole is MOL. And we put it equal to our given, which is 7.28 times 10 to the 28th atoms. We set our given over 1. Now I want atoms to cancel out, so it's going to have to go on the bottom of my next fraction. From our previous slide, we know that the number, Avogadro's number, 6.02 times 10 to the 23rd, goes with the unit atom. And that number is equal to 1 mole. So in my next fraction, I put atoms on the bottom and moles on top. To solve my problem, I take 7.28 times 10 to the 28th divided by 6.02 times 10 to the 23rd, and I get 1.21 times 10 to the 5th. A complete problem includes units, and my unit is mole because that's the unit that's left at the top of my problem. Let's try another practice problem. How many atoms are in 3.25 moles of xenon gas? Again, I start with my unknown, how many atoms, are equal to my given, which is 3.25 moles. I take my given and I put it over 1. Next, I need to consider what needs to go on the bottom of my next fraction. Because I want moles to cancel, I'm going to put moles on the bottom. The number that always goes with mole is 1. 1 mole equals how many atoms? Avogadro's number tells me that 1 mole equals 6.02 times 10 to the 23rd atoms of any element. Moles will cancel. To solve my problem, I take 3.25 times 6.02 times 10 to the 23rd, and I get 1.96 times 10 to the 24th atoms of xenon. Again, don't forget your unit at the end of the problem to have a complete answer. Now I'd like you to do some practice problems. Solve the first 2 problems showing all of your work. For problem number 3, I'd like you to explain how the mole and Avogadro's number relate to what we understand about a dozen equaling 12. Write your answers at the bottom of your notes and submit your answer in Schoology or give your paper copy to Mrs. Benke.